All right, welcome back everybody to the second video in the MCNA series where we're going to build out an MCNA, multi-cloud network architecture together using the Aviatrix platform. Now, in this video, I'm just going to go through an overview of the Aviatrix UI. I'm not going to talk about how to instantiate the UI because it's actually very straightforward. If you go to docs.aviatrix.com and follow the instructions, it's super simple. You can use a CloudFormation template to build it in literally, I don't know, 30 minutes or something. It's so easy to stand it up. I'd recommend you stand it up in AWS, the easiest way to do it, and you can hit the ground running here, and you can just follow along as well. So I'm going to give you this overview of the UI because I'm going to be leveraging it and jumping through it to build the MCNA together with you. And I want you to be as familiar with it ahead of time as I am so that you don't get lost. I'm going to go relatively quickly during this series because I don't want the videos to be extremely long. I want to keep your attention. I want to make this fun. I want you to be all eyes on the UI. So when you first log in, what you're presented with is this dashboard. And this dashboard gives you an idea of what you're building out during your MCNA configuration or build out. So right now you can see I have 3 different clouds onboarded into the Aviatrix platform. I have AWS, I have 1 AWS account, 1 Azure account, and 1 Google account. And what I'll do later is I'll add a second AWS account so you can see that we support multi-account and multi-subscription functionality. It's kind of like multi-tenant. It's really, really interesting. You can control all your accounts and all your subscriptions and all your Google accounts from one UI. It's really fantastic. What I'm not going to show you is how to onboard those accounts because it's super straightforward. There's a workflow you follow. It's really, really straightforward. If you go to docs.aviatrix.com, you'll see the instructions. I'm not going to waste time doing that because you can figure out on your own. It's very straightforward. So other than that, you can scroll down a little bit and you'll start to see as you build out your MCNA some geographic information. You'll see different clouds being plotted on a geographic map, and you'll see how they're connected to each other. It'll start to build out the peering connections, and you can hover over them, and you can see latency between the peerings. And when we build it out, we'll come back here and review it to see what's changing. Now, if you're building out an Aviatrix high performance backbone, then you can use this Aviatrix transit section. And there's nothing here yet because we haven't done anything yet. But the next video, we will build this. And it'll start to show you how the hub and spoke architecture looks as you build it out in a multi-cloud network. It's going to be really fantastic. If you scroll farther down, you start to see gateway metrics. Remember, we insert our gateways to add value where there are, I would say, issues or there's lackluster functionality in some of the clouds because it's still relatively new in the cloud era and there's still a lot of things like visibility and NAT and high performance and things like that that are missing in cloud networking that we can augment and add to your cloud networks by using our gateways. And so you can start to get metrics. You can pull all sorts of information from all the gateways that are deployed end to end across your MCNA. So this is really nice. And you can also export all this via logging and whatnot, which I'll show you soon. Also, you start to see controller metrics. You can start pulling information from the controller. You can graph it here. And then as we build out some of the other use cases, more information will start to show, like FQDN aggregation stats. And I'll show you what that is later on. It's another use case that we have in the solution. Another one is the VPN user count. If you're using our smart SAML VPN access client, then you can start to see information there. That's the dashboard. You can throw this up on your NOC. Like if you have a NOC at your organization, you can throw this up there and you can have a live view of what's going on. It's nice to have this there. Now you also have 2 floating bars that will always be there throughout your UI experience. You have this top bar and you have a left bar. Now the top bar has a shortcut to the different use cases that you can leverage for your MCNA build out. Now we'll go through all of these one by one later on, so don't worry about them yet. Then you have a little box over here where you can name your controller whatever you want. So when you log in, it's a little message. It's kind of like a message of the day, I guess you can put in there. You can put like, I like dogs, which I do. You can put whatever you want in there. It's not going to bother you. Oh, if you don't put anything, it says no empty string input, please. Look how polite these developers are. They put please in the error message. They must be Canadian developers. So let's put back to Dana's MCNA series. All right. Then if you have alerts, which I don't right now, we will later on, this little bell will show how many alerts you have. You can click it, and then it'll give you shortcuts to different alert areas. So let's say you have an issue with the routes and it did a route audit and found that your routing was incorrect. Well, it would give that information. Or let's say you had an update to your controllers that was available to be applied. It will give you a notice saying, hey, there's a new version of the controller and gateways code out there. You can click that and it'll take you to install it in the UI. There's also a help section here. Gives you information about the version of UI you're using. You can get to the API reference. You can get to the IAM access policy from here. You can get to the docs section from here. It's really, really nice area. You can even have a quick support email built out if you need support, which our support team is fantastic. I love our support team. They're super responsive and very knowledgeable. And then you have the user information here, right? I'm logged in as an admin, but you can log in as whatever. And then on the left side, we have all the navigation components, right? So onboarding an account, looking at the actual accounts, local or LDAP, whatever, however you're doing it. You have gateway page where you can see all your gateways listed and get information about them. Then you have a bunch of use cases that you can actually run through when you're building your MCNA. We're going to go through all of these. You have settings, and we're going to go through each one of these one by one in this video. So let's get started. So let's click onboarding and see what we got. Here is where we onboard all your cloud accounts to bring them under the administration of the Aviatrix platform so that you can easily build out your MCNA across all of these clouds. We have AWS, Azure, GCP, OCI, AWS Gov, and all the other ones that will eventually come will show up here in this page. So to easily onboard, you just click whatever account you're trying to do, let's say AWS, and you go through the workflow. Now, if you don't know what to put in these different fields, click the info button and it'll take you to the doc page and step you through it step by step. It's so super straightforward, very easy to onboard. Once you finish onboarding, then it'll take you and say, hey, number 3 is you can start building things like a next generation transit network, VPS egress security, remote user VPN functionality, right? There's a lot of things you can do. Multi-cloud peering, that's a cool one. We'll play with that eventually. So same thing for Azure, it gives you a little bit of a different workflow, different things it's asking for. But again, just read the instructions and it'll step you through how to onboard. You can onboard in 10 to 15 minutes per cloud account. It's very straightforward. And remember, this is multi-account, multi-subscription, so you can bring on a bunch of them. So if you click accounts here and click access accounts, we can see here are the different accounts that I've onboarded into my Aviatrix platform. I have my Azure account, my AWS account, and my GCP account. And later on, I'll add some additional accounts under AWS so you can see that we are a multi-account UI. It's really, really cool. Now, it'll also check to make sure that all your access rules and whatnot are correct. And so you can see that it did an audit to make sure IAM rules and access rules within the UI, within your cloud environment, are correct. And if they're not, you can go here and you can click update policy and it'll go through and check it and also fix your different rules and whatnot so that everything, all your API calls work correctly from the platform. Now, if we go to account users, this is looking at the local user database. So I have my Yanch at aviatrix.com user account. It's my admin. I also have an account for my Copilot, which I'll show you later on. It's an analytics platform, and I needed a separate account for that. But you can come here and build new accounts. Now, this is not the only way to log into your UI. We also support, SSO and SAML and Duo and all the different things that you expect, LDAP and all those things, right? This is a fully functional enterprise level platform. So everything you're expecting from an enterprise perspective will be there. I'm just not showing it to you here yet. So when we click account audit, what we're able to do here is run a forced audit on the AWS accounts that we have provisioned in the Aviatrix UI. And so what it's going to do is check all the IAM roles and rules to make sure they're intact and they're set up correctly and they haven't been messed with, so that the Aviatrix UI can push all the API calls correctly and have all the rules and permissions for that. Now, if there is something that's out of whack, and it does this periodically, does this check periodically, it will send an email notification, and it can do this audit in the background, and you can manually audit all the different accounts that you have set up. So it's a kind of a nice way to ensure that everything is how it should be when you're building out your MCNA. When we click the gateway section, we're going to be provided a list of all the gateways we've deployed across our MCNA. Now, usually you'll have a bunch of them, so you can use the search functionality up here to search through them, or you can sort through how the information you want to see on this screen. You can, customize that output, which is nice. Here you can also edit each gateway separately, meaning you can change information about them, the different settings that a gateway has. You can do diagnostics on them. You can delete a gateway, and you can view information like route tables and all such these things, like all the information about the gateways itself. Now, when we build it out, we'll come back and play with all these things. I just want to give you a quick overview of them. You can also build out a gateway from here. So we click New Gateway. Well, then it gives you this UI section where you can start building out gateways. It's going to ask you what cloud type you want to leverage, give the gateway a name, run through the region, the VPC ID, the public subnet you want to put it in, the instance size, right? Because you might have different sized gateways for performance and whatnot, and the different features and functionality you may want to enable. We're going to go through all of these different things, and I'll talk about what they all do later on, okay? All right, so then we move on to some of the different features we can start to build out for the MCNA. One of them is called the TGW Orchestrator. What that is, so in AWS, we have this thing called the TGW, the Transit Gateway. And so this allows us to control and configure and build a TGW, multiple TGWs, connect them to each other, connect different VPCs to the TGW, and it automates all the routing and all of the attachments and all the route tables and availability zones that are required for attachment with these workflows. So let's take a look at it. So if you click Plan, you're going to see here it's going to give information. Well, what do you want to do? What's the quick thing you want to do? Well, I want to fully connect my VPCs together. I don't want to segment them yet because we can do that. We can build out segmentation using your TGW, which is really, really cool. So we scroll down, you can see that everything is a workflow. So it gives you guardrails so you can't make a mistake. There's a lot of UIs out there that just like throw it at you and you got to sort through and figure it all out yourself, and you can make all sorts of mistakes. It's really hard to make a mistake in our UI because we give you these guardrails through the workflows. And even if you do make some mistake, like you added a character that wasn't supported in the transit gateway name, it'll give you that error and it won't even continue on. So it's really nice. It's a nice UI with a lot of protections in place, so you can make this an easy and nice experience for you as you deploy your MCNA. So very simple to build out a transit gateway. You can give the information it's asking for you here, and it says, well, you can also segment your network. So you go through the workflow of segmenting the network, and really what this is doing on the back end is building multiple route domains or route tables and connect them to the right VPCs, and then configuring the routing so that these different environments can talk to each other or not talk to each other if you're trying to create segmentation. And once you have these different domains created, secure domains, you can go through and say, hey, I want this domain to connect to this other domain, and we're going to do this together. So don't worry about it right now. I'm just going through it real quickly, just so you have an understanding of the different sections of the UI. And then you can create peerings from the TGW down to on-prem, or you can connect it to a transit gateway from Aviatrix. Really a lot of things you can do here. All right, so you go through, and this is the section that I'm talking about. Then we also have delete functions, right? So let's say you want to back out of something you just did, or you don't need something that you've created in the past. Well, you go through the delete functions and you delete the features that you had just deployed, and everything will populate for you. All the things you have deployed will populate for you because we, of course, keep inventory and we do audits and we know what you've deployed in your MCNA. Again, nothing here yet because we're going to build it out together. Don't worry. Under build, we have things like attaching a VPC, whether it's an existing VPC that you already have in your network or one that you create through our user interface. You can attach them to your TGW from here. Then you can also remove it if you don't want to attach it. Once that's done, you have a listing of all the TGWs, and you can go in here and edit the configuration of your TGW. This is really cool, and there's really nothing to see yet, but because we haven't built anything out, but we'll come and do it together. It starts to give you a little UI or a workflow, or what would you call that? Maybe a kind of a chart of how things are connected to each other, how TGWs are connected to VPCs and how VPCs are connected to other VPCs and what the policies are and all that stuff. So we're going to see that eventually. It's really nice. We have a functionality called Flight Path, which allows you to check the native constructs and the end-to-end path throughout your cloud network, whether it's within AWS to AWS, within region or multi-region, or if it's between AWS and Azure. and you have connectivity in place from your MCNA, it'll test the connectivity to tell you where it might be broken if something isn't working. Maybe it says, oh, you forgot to add a security group that allows that IP address in, or maybe your NACL was configured incorrectly, or maybe there wasn't a peering setup, or maybe the route table was incorrect, right? And so it gives you some good information, and we're going to test this out. You'll really like this feature. It's fun. So as we build it out, it's kind of cool to test things here. We can audit the routing in the TGW. So if somebody went in there and changed some of the routes after you had deployed it using the UI and they weren't supposed to do that, you can go in here and you can run an audit. Now it does this audit on demand, or you can set it to do it manually, or I'm sorry, you can set it to do it automatically and then give you reports. And then this approval thing is pretty cool. So if you have, let's say you have some configuration to connect to on-prem and via BGP, and you're learning some BGP routes, well, you can configure this gateway to approve, so that you have to approve routes before they even make it into the tables and get propagated by our controller. So you get more route control. And again, we're going to go into this together. The next section is the transit network, and this is where we can build out a high-performance global transit network using Aviatrix. It's a part of the MCNA. I think that's the first video we're going to do actually together in the next video that I create. So again, it's a set of workflows. You walk through it, 1, 2, 3. It tells you how to build out this transit gateway architecture. It even makes it easy to spin up an HA gateway, right? It's really as simple as, hey, this is the gateway name, the primary, and I want to now make it a secondary, right? And you tell it what subnet to use, and you click enable, and it spins up another gateway. It creates all the configuration, creates all the tunnels, it connects them all, does all the routing end to end for you. Super fantastic. And every piece of this workflow has a README. So you can click it and it directs you right to the documentation if you're curious to know more in depth as to what's really happening behind the scenes. And I think I'll show you some of that stuff that's happening behind the scenes whenever I find it to be relatively interesting. So after you build out your transit gateway, you can then connect it to a VGW or an external device like a CSR or an ASR on-prem, or whatever router firewall you have downstream on-prem, or to our Aviatrix Cloud N. The Cloud N is a hardware platform that runs our gateway code that you can actually buy and put on-prem in your data center or your co-location, so that you can run super high throughput, encrypted throughput over the internet or over your direct connects or express routes to have a really good performance, right? Because the VGW from AWS or whatever it is that you're using, cloud native termination point, is always going to be limited. Usually it's limited at 1.25 gigabits per second, which is pretty not so great, right? And a lot of times even equal cost of multipath routing is not supported. So you really can't get very good performance. But if you leverage our Aviatrix Cloud N, you can get incredible performance. It's really, really, really nice. Okay, so you build all that out, and then we have the spoke functions. Well, okay, we created the gateway, but now we need to bring in spokes. So we can say, let's launch some spokes in some of our VPCs that you want connected to your global enterprise global backbone, high performance backbone. Okay, so you spin up the different spokes in those different VPCs where your workloads live, and it'll automatically connect them to your gateways and handle all the routing end to end for you. Okay, there's a lot of features here. We're going to go into those one by one later on. Don't worry about it. Same thing, you can build out the HA, no problem there. And then you attach the spoke gateway to the transit VPC you just previously created. And also, if you don't want to use a spoke gateway in, for example, Azure, you can just connect a native connectivity using native peering in Azure to your transit gateway. That's supported as well, right? All sorts of supportability here. Whenever painting you into a corner, we want to add the flexibility for this MCNA so that it can meet your requirements, and your requirements change, and requirements are different from company to company. So we're not limiting you in any way. We have our recommendations, of course, we have our best practices, of course, but there's always ways to build it out to meet your requirements. Again, delete functions, right? So this is starting to get pretty familiar. You should start to see that it's just a workflow where you can build things and then you can delete things. Now, keep in mind, all this stuff that I'm showing you can be done via API, or more realistically, through Terraform, because we're a full Terraform provider, and you can just run these simple Terraform scripts to do all this stuff at super high scale, right? So you don't have to click things over and over again. Now, again, just like the TGW orchestrator, you get a list of all your transit gateways and your spoke gateways, and you can get tons of information like route tables and performance and all sorts of things that you want to see from your gateways, because these are basically a bunch of routers, right? High performance routers. And so you're going to want to be able to see more information about them, like diagnostic information, trace logs, and all stuff like that. So after you build out your transit network, you can start to build out a transit peering. Let's say you want to connect the transit network you created in AWS and connect it to Azure. Well, it's very straightforward. You say, well, yeah, this is the transit gateway 1, and we'll do this together. And then you would say, okay, this is the AWS transit, and then you can click the Azure transit, and then it'll build out a peering, between encrypted peering, high performance peering. This can be done within the cloud or between clouds. Very flexible there. Okay. The transit FireNet section is, we have this functionality where you can put firewalls in your transit gateway network and then leverage security policy to insert services, insert the firewall service in line in the path of traffic so that you can force traffic through a next generation set of firewalls like a Palo Alto or a Checkpoint or a Fortinet, and get inspection north-south and east-west in your transit. And it's very high throughput, high performance. I think it's up to 70 gigabits per second today. So it's pretty incredible. You can scale up those firewalls. And there's all sorts of benefits of leveraging our firewall insertion in our MCA versus trying to natively connect things via IPsec and BGP. You get much better performance with our connectivity model, and you have visibility because you don't have to use SNAT. And I'll go into some of that detail later on. All right, here's the policy for connectivity when you're building out the insertion and deploying, how to deploy the firewalls, how to manage the firewalls, and the delete functions, okay? There's an advanced configuration section here. We'll go through all this stuff one by one later on. But you can see information about BGP if you're running BGP to on-prem. You can create alerts and diagnostics, and there's some of the behavior you can adjust from a transit perspective. Like, do you want the transit to be transitive between VPCs, or do you want to not allow transitive routing between VPCs? You can configure that here, or you can manually adjust how networks are advertised, and you can prepend the AS path in BGP and all sorts of networking functionality that you don't get in a native cloud network. When you leverage our gateways, you get all sorts of additional things. Again, the approval feature, I showed you that before. As routes come in from BGP, you can have them set to be approved before they make it into your network. And this is really cool, right? If you think about it, there's no functionality like this today in any cloud. If you're running BGP with a partner, you want to be able to control what routes that partner's sending you, but you don't have control of your partner's router. So they could send you anything, and they could send you overlapping CIDR or a more specific prefix and totally mess up your routing, right? And so what we've done is we've inserted this control where we can add an approval process. So before the route even makes it into your network in the cloud, it sends your administrator an email and saying, hey, there's routes to be approved here. Go in and see the routes that have changed, and you can either manually approve them or deny them, and now you have full control of routing in your cloud. This is just an incredible feature, and I think a lot of my customers are just blown away by this because they don't have this functionality in native cloud today. Now, this next section called Firewall Network is similar to what I showed you called Transit FireNet. That's where we place firewalls into the Aviatrix transit network that we build out. Now, in this case, we're leveraging service insertion of firewalls, next generation firewalls, Palo Alto, Checkpoint, Fortinet. But instead of putting them inside the transit FireNet, the transit network, we're putting them in their own VPC and then attaching those natively to the TGW. So it's a little bit of a different model. It accomplishes a similar thing. Yeah, you have some more functionality here around segmentation and policy, but in the end, you get the same firewalling functionality, east-west, north-south firewalling, super simply with all the routing done for you, end-to-end. And you can create the segmentation policies, and there's some vendor integration that we have, like we can configure the routes on the firewalls. We can spin them up through the UI, so you don't have to manually do that. So you just run through this use case and you just do the workflow. What, 1, 2, 3, just follow the workflow. It's very, very straightforward. It's really hard to make a mistake in our UI. Of course, I've made a million mistakes, and that's how I learned. But that's just me. And you shouldn't have to make any mistakes. Sometimes I purposely make mistakes just to see what will happen. And a lot of times the UI is pretty smart. It'll tell you, no, you know what, you're doing something wrong. You need to do it this way, right? Which is really nice. Because I hate having a UI where you go through your whole thing and then you made a couple mistakes. It tries to deploy the whole thing and then it fails, right? You just wasted 15 minutes of your time. Why didn't you tell me that it wasn't going to work at the beginning, right? So you can save the time. That drives me crazy. But that's not the case here. A lot of times we are going to make sure you're not going to go down that rabbit hole and then fail, right? We'll tell you ahead of time. So save some time. All right, so you deploy the firewall network, and again, this is going to allow you to configure a Palo Alto from scratch. It'll also spin it up and connect it, and build all the interfaces, connect it to your cloud environment, do a connection to the TGW, and then do the routing and all the firewall policy, and configure the routes on the firewall. It's really, really nice. Don't worry about this. Once the actual firewalls are deployed, you get information about the firewalls there. We'll come back when we do actually build this part as a part of our MCNA. The vendor integration piece is how you get the API in the Aviatrix controller to talk to the APIs in the firewalls, so you can configure the firewalls and their routing. We'll do that together as well. And now for one of my favorite features in the Aviatrix platform, it's called Cloud WAN. And I actually wrote an article about Cloud WAN, which should be published sometime soon on LinkedIn or on our blog. But Cloud WAN, the reason why I like it so much is because it reminds me of SD-WAN. It's kind of like that world that I lived in before, but it's super simple. And it's so useful for organizations that have realized that, hey, it's important now for me to connect to the cloud directly in the most efficient and optimized way instead of having to go back to a data center and backhaul through the data center, right? And so what we're doing is we're registering your branch router in our UI so we can control it, we can configure it, and we can connect it to the closest entry point into AWS or Azure and have it reach your workflows in the most efficient way possible. And the way this happens is that you give the UI your branch router's management information, management IP information. And today we support just iOS and iOS XE Cisco routers. I'm sure down the line we'll support Juniper and all sorts of other platforms as this becomes more of a common use case. And then once you register the router, it should show up in the list section, and you can see that router in here to see if it's registered correctly, and it'll give you a state. It'll be green, red, yellow. If some things are not correct, then you can go through and modify what you've done. Right? We'll do this together. And then you can attach the router to your transit gateway or to your AWS TGW, and in the future, the Azure Virtual WAN. I know it's here, but you can click it, but it won't do anything yet because it's a feature that's coming. But Aviatrix Transit Gateway and the AWS Transit Gateway you can connect to. So what it's doing at this point is reaching down into the router, configuring tunnels, configuring BGP, configuring the routing, and the security rules and all that to connect back to your cloud. Now, the cool thing here is that, especially if you're using AWS, is that AWS has something called AWS Global Accelerator. And so you can take a very special Elastic IP, EIP, and have that as a part of the Global Accelerator section. And then what will happen is that becomes an Anycast address around the world, and your routers will connect to the closest IP address to ingress AWS. And then once it ingresses AWS, it'll take the AWS private backbone to reach your transit gateway and then to reach your workload. So you kind of, what it's doing is it's kind of regional. It's connecting to the closest regional AWS POP and then routing the nice congestion-free, high-performance backbone of AWS to reach your transit gateway or to reach your TGW. How fantastic is that, right? Now you don't have to hop by hop over the internet to get to a certain endpoint to build your IPsec tunnel. We're getting to the closest endpoint to build your IPsec tunnel. So you can see Enable Global Accelerator is right there. And you can go and configure the different algorithms if you want to be very specific as to what you're doing from an IPsec perspective. Okay, very straightforward, very nice feature. Once it's onboarded, you can also delete them from here. But then we have something called where is it? Actually, it's under here. Configure, no, Network Manager. Where is that? Config tags. No, it's not there. It's under list edit. So actually, once you have these gateways deployed, you can then edit their configuration, right? So we'll actually download the configuration or upload, whichever way you're thinking of it, into our UI, and you can manage it and have different versions of the configuration in your UI, and you can make modifications from the UI. So you can update the config from here. You can create different versions. You have version control, push down new versions of config to the router downstream. It's very nice. You can also create little templates here. So we call them tags actually. You can give a tag like, let's say, the banner. I don't think I was playing with this before. You can create a banner and say, you know what, banner, MOTD, I like dogs. I don't know, whatever you want to put there, right? And then you give that tag and you apply that tag to a particular group of routers that you're under management. As you can see, attach these to the branch devices. And whenever those branches come online, it pushes that config snippet down, right? Kind of interesting functionality. I'm sure we will use that in our MCNA to play with it. Now, there's also AWS Network Manager integration. If you haven't heard of that, go read up about it. I'm not going to tell you what that's all about, but it's pretty straightforward. It gives you a nice little geographic map and some inventory of the different IPsec connected endpoints to your AWS environment. So maybe we'll play with that. Maybe we'll go configure a couple of those when we're building out the MCNA, but that's not really important for the MCNA. It's just an additional feature that we have, an integration that we have with AWS. In this next section called peering, what we're doing is orchestrating connectivity between gateways or between clouds using peering functionality. So that could be an encrypted peering, leveraging our high performance backbone, or just a high performance IPsec connection between two gateways or two transit networks, two transit gateways. You can just click here, add new. It asks you what's gateway 1, what's gateway 2. And if you want to do HA, so you have additional tunnels and automatic failover, you can hit OK, and then it'll build that out for you. Very easy to do IPsec peering, and we support ECMP and multiple tunnels active at the same time and high throughput, right? Very nice way to create peering across your network. Also, we have AWS peering. Don't worry about this transit peering thing right now. I think that's deprecated. I'll come back to that another time. But we have AWS peering and Azure peering. What this is doing is saying, hey, we can also orchestrate the native peering functionality that exists in AWS and Azure. If you don't want to leverage an encrypted peering, you want it to be an unencrypted peering and just do the native peering functionality, you can do that as well. So straightforward, you give the information about the peer 1 and peer 2 in AWS, hit OK, and it'll build out that for you. Same thing with Azure, same idea, okay? This is an easy way to create peering, so you don't have to go through and configure all sorts of routing and next hop configuration and create the peerings on each side manually. It does it really all for you via these workflows and API calls. Very, very nice way to make your life easy and efficient when building out peerings in the MCNA. Okay, what we're doing in the site to cloud section is basically orchestrating standard IPsec tunnels from your cloud network, Aviatrix Transit, whatever it might be, to some other device like the on-prem network, like an ASR or a Palo Alto, or maybe a VGW or an Azure VPN gateway. So really it's straightforward, right? You click add new and you give it a name, and then you can create mapped or unmapped. We'll talk about that later. It has to do with NAT. And then you specify the type of gateway. So is it just a generic IPsec, like a standard IPsec gateway, which means it can be anything? Or is it an AWS VGW, an Azure VPN, another Aviatrix solution, a Sonic Wall, Oracle, OCI, Meraki? That's interesting that they have Meraki in here. But yeah, basically you can have all these things and it'll actually build out the local side connection, meaning it'll build out all the Aviatrix or the local connection, and then also the remote, and then you can download the configuration of the remote side so you can go and throw it in your remote appliance. So it makes it very easy to onboard IPsec tunnels and get traffic in and out of your transit network or in and out of your Aviatrix MCNA environment. So this is a really easy way to do it. Now, you can also deploy site to cloud tunnels using some of these other workflows. Earlier, I showed you, hey, there's a workflow about connecting transit gateway, for example, to an on-prem device. What would happen is that it would then show under the site to cloud tunnel section something that was created from an earlier workflow, and you can adjust and edit everything from here as well. So you don't have to always create everything from this section. It might be created in a separate workflow as well, just for ease of operations. You can also import configs if you had them pre-created as a template. And you have diagnostics. You can run information about, get information about the IPsec connection. And of course, if you're not getting IPsec tunnel come up, maybe you had the wrong key or source IP or something like that. You can go here and run some audits and get information about it. Okay, very straightforward way to build tunnels, encrypted tunnels in and out of your network. Up next, we have the OpenVPN section. And what this is our implementation of a user access VPN with extensions on top, right? We have SAML and Duo and all sorts of policy and firewall functionality and NAT functionality that you can leverage using our gateways. Because what this is doing is spinning up gateways behind a load balancer if you have multiple gateways to deploy for HA or for scale, and then onboards clients through either using a native OpenVPN client or our client, which has additional extensions built into it for authentication and security purposes. And so it's really an easy way to build an ingress, a secure ingress and egress out of your cloud network. Now, this is actually going to be one of our earlier use cases we're going to play with in the MCNA series. So I'll leave the details to that, but it's pretty straightforward. You have the information about the users that you've onboarded. You have the advanced section, of course, for GeoVPN, which is cool. So those users can connect to the closest VPN ingress point to get higher performance, I should say. And then you have a UDP load balancer. This is actually for, again, higher performance, higher throughput into your VPN gateways. And then additional functionality here. We'll talk about that later once I actually learn myself. Because some of these things I don't even know myself, like certificate. I think you can, okay, this is just a traditional PKI cert that you can push down or you can leverage as a part of the onboarding process. But yeah, it has some other things in here I'm actually not completely familiar with myself because I haven't had a chance to deploy it, but we'll do it together and we'll learn some of that together. All right, so you can go in here and edit the configuration after you've deployed it. You can create profiles, and profiles are neat because you can actually create a profile for a specific group of individuals. Let's say they're dev individuals, and you only want those dev individuals to log in to the remote access VPN and access certain CIDRs or certain VPCs within your network. But you can create a specific profile for them, and when you create it, you can say, hey, these users onboarding are only ever allowed to reach these particular CIDRs or these particular VPC endpoints. So it's very nice way to add policy to your VPN functionality, your access VPN functionality. And there's of course a troubleshooting section to play with different troubleshooting if you need to do that. I haven't had to need to do this because the product actually works perfectly every single time for me, but eventually we'll have a chance to play with this. Onto the security section of the UI, we have something called Stateful Firewall. Yes, it's exactly what it sounds like. It's a stateful firewall that you can deploy on every single gateway that you have implemented in your MCNA. And this is cool because we have something called a tag. And you can create a tag, and in that tag, let's say it's called Dana. Put my name there. Oop, put my full name there. Okay, let's see what happens if we put that. Oh, it doesn't let me, it says you cannot have a space. Okay, it doesn't like my full name. Let's put just Dana. All right, we create a tag, we can edit that tag, and we can add CIDRs to that tag. So we can leverage this and say CIDR 1 and give it a 10 dot, sorry, I'm trying to type with one hand because I'm getting tired. 10.10.10.0/24. All right, we can throw us another CIDR, it's called CIDR 2. This would be 10.10.20.0/24. And then you can leverage this tag in the actual policy later on. I can't share the policy yet because I don't have any gateways to build a policy on, but once I do, we'll come back here and build that together. But building a policy is just like building any other layer 4 stateful firewall policy, right? Source IP, destination IP, port, protocol, match, action, accept, action denied, log. Then you can leverage these tags. Let's say we want to match Dana. Okay, well, it's going to match all these CIDRs that were in the match Dana tag. So it makes it easier to scale out your policies in the stateful firewall. Very easy to deploy and configure and manage and monitor on our gateways. Egress control. This is a very commonly used feature in the Aviatrix platform. What this is basically is a lightweight solution to control what your instances in your VPCs are able to access out on the internet. And so what we're able to do is spin up a lightweight gateway in your VPCs, and then your instances will leverage that as its next hop to reach the internet. And then we can do inspection on what they're trying to reach based on FQDN, right? So this is an FQDN-based solution. It's not an IP-based solution, although you can leverage IP addresses. However, what we're trying to do here is make your life easy and leverage FQDNs, because IP addresses change all the time. You can't control that, but FQDNs usually don't change very much. But if they do change, we support wildcards, and so you can put in a star dot something, star.microsoft.com. So all those domains are either restricted or allowed. So we support a whitelist or blacklist model, and then you can create a completely different FQDN filter per gateway, per VPC, and it just allows you to have easy visibility and control of what your instances are able to reach out on the internet. And so, it's probably better and cheaper and easier to manage than it would be to throw a bunch of firewall, like expensive firewalls everywhere to do the exact same thing, right? So this is a very heavily leveraged feature in our platform. We'll go through this one actually as one of the use cases because it's just such a cool one to play with, and you get some cool stats to see what people are reaching out on the internet for. Actually, what's cool is that there's a discovery mode where you can put in discovery where it's going to take a look at all the different websites and FQDNs that are being reached out, or API strings that are being leveraged as it goes out to the internet, as your instances try to reach out to the internet. And then you can build your policy based off of what you've seen from that discovery mode. So it's, I thought that was really clever. I like that functionality. Now, the AWS Guard Duty and the public subnet section kind of go hand in hand, and they have components of the egress control feature I just talked to you about. But really, what's happening here is if we skip the public subnet, we can do the same type of egress filtering on public subnets as well, as those public instances try to reach the internet. So the same egress control as traffic egresses the VPC towards the internet, but also we have ingress control as well being leveraged through AWS Guard Duty. If you haven't heard of AWS Guard Duty, it's kind of like like an IDS, solution, intrusion detection system, where it's taking a look at well-known or bad IPs or sources, and then alerting you that, hey, there's all these different bad IPs or bad sources trying to ingress your network, and it gives you an alert and information about that. But what we're doing as an extension is we're deploying the AWS Guard Duty in addition to the egress public filtering, so that what happens is that whenever AWS Guard Duty has an alert or sees something bad that's happened, we'll update the ingress filters on the gateway to not allow in those bad IPs. And so we're now turning this in from an IDS into more of an IPS solution, and it's all automated, right? It'll automatically pull the AWS Guard Duty resource and then update the firewall rules, update the FQDN rules, ingress as it comes into the gateway. So now you have both ingress and egress security for your VPC. Really, really slick solution. Next up, we have private S3. This is a very unique solution that only Aviatrix has out in the market for a problem that a lot of people are running into, and it really has to do with confidential data leakage when it comes to accessing S3 buckets. Right now, the way it works is that you access an S3 bucket over a direct connect, and it requires a public VIF. So that means that all the IP addresses of those buckets are being advertised downstream. And so really what can happen is that a user can leverage their own private or their own personal buckets as well as their corporate buckets, and that can allow for data leakage, right? So it's not a nice way, not a very secure way to leverage the cloud storage functionality. And so what we're able to do is insert our gateways in between, and then kind of be like a man in the middle, and then selectively expose certain buckets downstream so that only some are available and the others aren't to end users. Now I'll go into more detail. We'll actually run through the documentation real quick when we deploy this as a part of the use case. But right now, that's enough information for you to understand what the point of this section of the UI is for. And lastly, in the security section, we have the FQDN stats page, and this will all populate with FQDN information from the egress control and the public subnet functionality, where we're managing who's allowed to talk to what out on the internet. And it gives you a very nice output with cool graphs and statistics and analytics as to what's happening as your traffic egresses to the internet. So we'll populate this and show that later on once we deploy that use case. Let's jump to the useful tools section. I think you'll find some interesting things in here. So the first thing called Create a VPC does just that. We can create VPCs directly from the Aviatrix UI. And so we can build a VPC for AWS, or we can build a VNet in Azure. And it just asks you the basic information, right? What do we need to build a VPC? Well, we need a name, we need the region, we need the account name, we need the CIDR that we want to throw in there. And so you can do that and it'll build it out for you. It's an easy way to create VPCs. Now, there's very specific reasons why you might want to use this. Let's say, for example, you're building an Aviatrix Transit VPC or one of those FireNet VPCs I talked about before. Then you'd want to use this for sure because it's going to break out the subnets into other subnets. Well, it's going to break out the CIDR into other subnets specific for these particular use cases that are needed, right? And so it does that for you. It's pretty nice. Now, we also have a VPC tracker, meaning we're going to pull the environment and gather what CIDRs have been used and where, and you can search through them, and you can see how many instances are in each one of these different VPCs, and you can export it to a CSV. It's kind of like pseudo IPAM, IP address management tool, but it's interesting, it's useful because we don't want to run into overlapping CIDRs. That causes all sorts of problems, right? And if you do, you need NAT, and it's just a pain. So we want to make sure we don't run into overlapping CIDRs whenever we're designing our network not to have overlapping CIDRs. And so we can do things like this. We can check to see if there's an overlapping CIDR. So let's say I'm curious to deploy a new VPC. I want to know if 10.99.0.0/16 is being used yet. So you click test. Look at this. It says bad news. Look how polite they are. I love how polite these developers are. They say bad news. CIDR 10.99.0.0.16 overlaps with at least one network. And then it tells you what the VPC is that is overlapping and where it's located and all that information. So it's a really good little database to get information from when you're deploying workloads in your cloud. Export to Terraform allows you to take any of the functionality in the UI and export it to a Terraform script or anything you've already deployed and export it to Terraform. And so if you're not familiar with Terraform, go just look it up real quick and get an idea of what it's all about. But it allows you to have repeatability in your cloud deployments using the Aviatrix UI. We're an official Terraform provider, so you can go to the HashiCorp website and get our documentation around that if you're interested in automation and repeatability and orchestration using our solution. But let's just say we clicked on peering. So let's say we're curious about creating automation around peering with tunnels. So we can click download the TF. It gives you a little zip file. We can open that up. Let's open it up, see what's in there. Oops, I opened it up twice. And then you can take a look at the Terraform script. Let's open this with my Atom browser. No, there's nothing in there. Why is there nothing in there? Oh wait, maybe I opened the wrong one. Let's open this one instead. Let's open with TextEdit. Oh, you know why? Because I haven't deployed anything yet. So once I start deploying things, you'll be able to see stuff that it's in there. Let's go back and see if there's something that has been deployed. Is there anything? Oh, accounts. Okay, that should be a good one. So let's click download TF. All right, accounts. Please, God, have something in here so I don't look like an idiot again. All right, TextEdit. There we go. So you can see information about what we're doing from a Terraform perspective, and you can leverage this in your scripting. What's in this one? Let's open that guy. Okay, yeah, just more information with the Terraform scripting. So you guys, I'm going to invite a guy in our group who's pro at Terraform, because I'm obviously not pro at Terraform, and he'll do a demonstration for us and show us some repeatability and some orchestration using Terraform. It's gonna be really cool. He showed it to me one time before, and I thought that was really awesome. So I'll show that to you guys as well. All right, we're nearing the end here, or almost there. Just hold on a little bit longer, and I'll get you guys to the end. So we have the settings section, and under there is the maintenance. And here's where we can do things like upgrading your controllers and your gateways. And so whenever there's a new version, you can run this and it'll upgrade the entire infrastructure, and it's hitless. That's really cool. You can upgrade this whole of infrastructure hitless. It doesn't cause any type of data plane outage. You can also do a dry run to make sure that that controller code is going to work correctly, or that gateway code is going to work correctly. Or you can upgrade to a custom release. Let's say our dev team created a custom release with some special features for you. You can do that from here as well. You can do backup and restore of the controller architecture from here. That basically backs it up and restores it via an S3 bucket. You can do migration, so you need to move everything over to a new controller, you can do that as well. And then you can selectively apply security patches and software patches to the environment. I really like that we are able to break that apart and be very specific as to what we want to upgrade, whether it's on the controller or on a gateway. Very, very nice functionality. They've really thought through this from an enterprise level functionality. Okay, then we can go to the controller section. This is everything that has to do with controllers, this controller, I should say. And so that's like the system time, the licensing information. I'm going to hide some of that because I don't want you to see that. The email information as to where email alerts should go to, LDAP login, SAML login, two-factor login, and everything else that you'd want to configure from a controller perspective. There's also logging. We support syslog, standard syslog, export to Splunk, FileBeat, Sumo Logic, Datadog, and NetFlow. We can support the export of all this traffic to NetFlow, so you can get some more sampling and get more information. We're actually going to enable that and play with that when we configure Copilot, which is an analytics platform that we have that we can play with, and also a CloudWatch agent if you're leveraging that as well. If you go to the advanced section, it starts to get deeper and deeper. We don't need to go into any of these details. You can go play with this on your own, but a lot of times you don't even need to mess with this stuff, but it's here for when you need to, if you ever have a specific use case. Actually, this one's cool. We actually check to see if the gateways are alive, and if they aren't, we can reprogram routes to point to other gateways in certain instances, and you can change the interval of as to how often these controllers are pinging, or it's not really pinging, but checking the endpoint, right? The gateway. Kind of cool there. Let's go over to the troubleshoot section. Here we can grab the logs from the gateways. I'm sure you've grabbed logs from routers before. It's the same thing. You can pick your gateway once we have them deployed, and then download and view the logs. And you can send those to our group, or you can just search through them yourself if you want. And then we have a diagnostics page. This is really interesting. So there's a lot of diagnostics in native cloud networking that's missing, like in AWS and Azure and GCP. They're missing a lot of things, like net flow information, or just basic packet tracing and packet walks, and what's another one? Packet capture, right? That's a big one. So that's missing. And in the future, we're also going to have iPerf testing, so we can check performance from endpoint to endpoint, which is going to be really nice here as well. But yeah, we have all the different diagnostics. You can see here's the packet capture on a gateway. So if you have a gateway in your network, of course, traffic is going in and out of it, and you can leverage that as a point to capture traffic and do some troubleshooting with that. Okay, and then you have a very specific gateways diagnostics. I'm not going to go through all this. Cloud diagnostics, I talked about this before, the auditing of the clouds and their routes, and if they're as we expect them to be, and BGP and services and the database that runs in the box and all sorts of things. Okay, this is just what that section is for. If you've deployed ELBs, if you deployed a load balancer in the environment, you can get status on that as well. And lastly, finally at the end, flight path. I talked about flight path just a little bit before, or actually earlier in this conversation, but this is a different section to reach that same tool. But really what you're able to do is pick an instance or an IP in your environment as a source and as a destination, whether it's within the region of the same cloud, or multiple regions in the same cloud, or across regions and across clouds. You can basically specify that here, and it will run a test end to end and look at all the different components in between from a networking perspective to tell you if something is broken. And so we'll run through one of these later on as we build the network, but you'll be able to see that, hey, you know what, we configured everything, and then the next day your partner came in and made a change to a security group, and that screwed up something. And so instead of trying to trace back to figure out what happened, you can go through here and run a flight path, and it'll tell you, hey, that security group in the destination environment is not allowing in your source IP, and that's the cause of your outage or your network connectivity problem. And so it's really nice that it's able to look deep into each cloud and tell you where things are breaking from a networking perspective. Having to do this manually, I've been doing this manually for a long time, and it's horrible, right? You have a million tabs open, and you're getting lost between different cloud environments, or even within the same cloud and different accounts. It's just horrible. It's horrible to troubleshoot any type of networking functionality or networking problem in a cloud network. It's just not like you're used to on-prem or in the old days, right? Or can we call it the old days now? I guess it is the old days because we're entering the multi-cloud era. On-prem networking is old days. Goodbye, on-prem networking. So guys, go get all your certs in cloud networking. Stop wasting time on the old school stuff. That's my advice for today. And that's the end of this session today. The next one we do will be the first build out, the first use case that we build out in the MCNA. And I think it's going to be the high performance transit, global transit setup. I think that's a nice place to start. Now, probably won't get a video next weekend. I'll try. I'm actually going to be in Australia, and I'm like upside down over there with time, and it's just going to be difficult for me to get something done and uploaded. But I'll do my best for you all, and hopefully this was helpful, and I'll see you next time.